So what is the concept for normal type of problem in projection of solids? So the concept here, it is very simple. If the angle of inclination it is given with respect to HP and VP, if it is there with the base edge and axis, so you can see that one of the inclination will be there with the base edge and other inclination will be there with the axis. So then it is a normal type of problem. So it is very simple. You need to see in the question the angle of inclination either to the HP or VP if it is given with the base edge, and angle of inclination either to the HP and VP if it is given with the axis. Then the problem will become normal type of problem. Okay, normal type of problem in the projection of solids. And the same concept hold goods for the prism, pyramid and cone. Okay, the same concept apply. Problem number 5 from CAD solution book. So what is given in the question is a pentagonal prism, dimension 25 and axis length 60. So rests on HP on one of its edges of the base. So we have to get the edge on the right hand side. So which is inclined to VP at 30 degree. So here it is base edge inclination to the VP at 30 degree. Draw the projections of the prism when the axis is inclined to HP at 40 degree. So here it is a normal type of problem because angle of inclination they have mentioned with respect to base edge and the axis. Okay, that's why it is normal type of problem. Okay, now we will construct. First we are going to construct an XY line. So we have to construct a pentagon with respect to edge on the right side. Okay, so dimension 25. So now we'll take protractor and mark for 72 degree on either side. Okay, from that reference point we are marking at 72 degree and drawing a line of length at 25 to that marked angle point. Again keeping at the another end point, marking at 72 degree and drawing a line of length 25. Okay, now taking compass, measuring 25 mm length, so we have to cut 2 arcs from that reference point. So join it to complete the pentagon. So now we are going to mention the dimension 25. Now we write the namings, top face A, B, C, D, E and bottom face A1, B1, D1. So all the things written in bracket because bottom face not visible from the top view. Now we draw perpendicular bisectors by marking middle point of any 3 edges and drawing thin lines here. Okay, so herein we are drawing thin lines to find out the center of the axis. So remember it. So in prism we are drawing the thin lines. So O1. Now project it upward to complete the front view. Okay, the front view of a prism, it is a rectangle. So here we have to construct a rectangle for a length of 60 mm. So first I am constructing an axis for length 60 mm. So we are going to construct a rectangle here. Now writing the notations, which are the ends visible, we write without brackets, and which are the ends which are not visible, so we are going to write down with the within the brackets. Now second, it is second position written with the base heads inclination. So base heads inclination is equal to 90 degree minus angle of inclination to the HP, that is 40 degree. So 90 minus 40 degree, it is 50 degree. So first I will take a reference point of D1 dash and C1 dash, taking protractor, marking at 50 degree. So mark at 50 degree and draw an angle line passing through that point. Okay, draw an angle line passing through that point. Now we have to cut the arcs for the base heads. Okay, so cutting the arc using compass from D1 dash to A1 dash, then D1 dash to B1 dash, then D1 dash to O1 dash. Okay, now writing the notations. So A1 dash, B1 dash and E1 dash, O1 dash. Okay, now you see these vertical edges are exactly perpendicular, so that's why from all these points we are placing the protractor and marking at 90 degree to draw the exactly perpendicular lines. Okay, so on all those reference point we are marking at 90 degree, so we have to draw perpendicular lines. So mark at 90 degree. So now, so draw a line of length passing through these points at a length of 60 mm. Okay, so draw a line of length passing through that point, length will be 60. So writing down the notations. So now we are extending the axis to show the angle for angle of inclination to HP. Extend the axis and check the angle. So here we are getting the angle of 40 degree. Okay, so inclination to HP is 40 degree. Now project the lines, project it downward, project the lines, project it. Project it from this end also. Okay, first writing the notations for the bottom face. So here it is A1, B1, C1, D1 and E1 and O1. Similarly A, B, top face, we are writing for the top face now. A, B, C, D, E and O. So now we write the outer boundary line. So that is what the first step, writing the outer boundary line. Okay, connecting all the outer points to draw outer boundary line. So constructing the outer boundary line. Now visible face, the top face it is visible, that's why we get the continuous pentagon here. And then edge, you see A dash and A1 dash, that is also visible. So continuous line. Now you see bottom face not visible from the top view, so that's why a part of the pentagon will be written with a dashed line. Okay, now the slant triangle rectangular face D1 and C1 not visible from the top view, that why it is also dashed line. Okay, so part of the axis we show it. Now we have to draw an angle line for the base edge inclination. So base edge inclination will be drawing angle line like this. Inclination to BP 30 degree. So we have to make sure our third position diagram should not merge with the XY line. Okay, so when we construct, so from D1 to C1 we can cut the arc. We have to place the resting edge on that angle line. So it is merging, so we should avoid that. So we can take that angle line little lower here. So we will take the angle line so little lower here. Okay, so mark the reference point and mark for 30 degree. So D1 is the reference point. From D1 to C1 we have to cut the arc. From D1 to D and C1 to C. Okay. So now it is reverse. D1 to C and C1 to D. Reverse we have to cut. So that is D and that is C. Using compass we have to construct two pentagons here. So the lengths will be here remaining same. You just measure it. D1 and D1 it is exactly equal to D to E and C to B. Okay, C1 to B1. So those are all the same lengths. Okay, that's why I am taking that only one length and cutting the 4 arc, because all those 4 lengths are same. Now it is reverse. Okay, D1 to B1 if you measure, and that will be used for D1 to B1 and C1 to B1. Okay, that will be same. Okay, now from D1 to A1 and C1 to A1, that is also same length. Okay. So now you have to write the namings. It is E1, A1, B1, that is E, A and B. So now O1 we have to cut. D1 to O1 and C1 to O1. Same C to O and D to O we have to cut. Okay. Now we have to join all these points. Using scale we have to join. First we are going to join constructing a pentagon. So wherever the dashed line is there, so we are going to draw the dashed line. where there is a continuous line, we are going to draw with the continuous line. Okay. So part of the axis, you can show part of the axis. Okay. Now the nearest point to XY line, you see here it is D. Okay. So D is the nearest point to XY line. D is connected with C, and D is connected with E, and D is connected with D1. So these are the dashed lines. Okay. Now we write for the top face, and considering top face, we write the notations first. So writing down the notations carefully here. Similarly for the bottom face also we write the notations. Okay, first we are going to construct the dashed lines. You see this. So D dash to E dash, first dashed line. Okay. Then D dash to C dash. Then from D dash to D1 dash dashed line. Now everything, now remaining thing will be written with the continuous lines. So first we are going to construct the pentagons. Finally there is an axis. Okay, this completes the problem. Good morning all of you. Today we are going to start first problem in projection of solids. So with the prism. So we know that in the projection of solids we have to consider the right hand side reference for placing the base edge or the base corner. Okay, say just for an example, say you can see that this is our pentagonal prism which is having top face and bottom face. So you can see that this is our base edge. Okay, base edge, and this is our base corner. Okay, so we have to place it with the right hand side reference, and we know that our first position starts from the HP plane. Okay, so that's not the thing. So how the problem proceeds here, say consider, so this is our first quadrant. Say, see, this is our pentagonal prism. Say I'm placing with the right hand side reference. So right hand side reference means this side. Okay, right side. First position, drawing the top view, front view. You can see that you have two faces, top face and bottom face. Then drawing the top view, front view. Second position, it is a inclination, right side inclination. Okay, inclination to HP and then top view, front view. Similarly, inclination to HP was already given, so it is inclination to VP. Okay, so understood, right? So it is what the inclinations, you can see that first position, inclination to HP, then inclination to VP, like this. So now we will proceed with the problem. Say in this problem we have to construct a square prism here, XY, VP, HP. So you can see that we have to construct a square prism. So of square prism of dimension 35 mm side, of base and axis length 65. Rests on HP on one of its edges of the base. You can see that. So say consider this is your square prism. So this is having, we need to construct with the base edge here. Okay, so here we have to construct the right hand side, we have to construct the base edge. So if you consider a square prism, the top view, okay, the top view of a square prism, it will be a square, correct? Square which is having top face and the bottom face. That means you need to construct a square here, square of dimension 35. Okay. Okay, so we have drawn a square here. You can see that. So in the square prism, we have two faces, top face and bottom face. So top face will give A, B, C, D, like that. If you take this duster, okay, top face A, B, C, D, which is visible to us, and the bottom face, which is not visible from the top view, so will be giving A1, B1, C1, D1. That will be in bracket. Okay. So the top face notations are A, B, C, D. Similarly, bottom face notations are A1 in bracket, B1, C1, similarly D1. Okay. So now this is what the top view, and there will be an axis here. Okay. There will be an axis connecting the top face center and the bottom face center. We need to find out the axis of the center. Okay. So how to find the axis? And we will draw the diagonals here. So diagonals will be thin lines here. Okay, draw with the thin line. So here exactly the top face center O and bottom face center O1, which is in bracket. Okay, now we know that we have to draw the front view. Say if you consider this, this is as your square prism, then we have drawn the top view. Okay, top view of it with the two faces. Say when we are looking in the front view, we will get a rectangular face here. Okay, rectangular face. For that rectangular face, they have not mentioned anything. Instead of that, they will be mentioning a 65 mm axis length. Using the 65 mm axis length, we can draw the front view. So we know that axis center connecting the top face and the bottom face, which is having an axis length of 65. So by projecting, okay, these are the projection lines. Direction. So using the axis length, 65 axis length, I am drawing the front view. We know that front view is a rectangle here. So remember it, front view of a prism. The front view of a prism in the first position is always a rectangle. So first I am drawing an axis line here. So axis line of dimension 60 here. So first I will draw an axis line, so which is having a dimension of 64. Okay, so using this axis length, I am going to construct the rectangle. Okay, so in the front view we get a rectangle. Now we have to write the notation of it. So from the front view we can see that So from the front view, so you consider this is your front view. So we can able to see from this front view B, B1, C, C1 visible, but A1 and D1 not visible, correct? So you can see that. So from the front view we can able to see these ends B, B1 and C, C1. So first I am going to finish with the top face. You can see that. So B dash it is visible, C dash that is also visible, but A dash it is not visible from the front view, and D dash not visible. You can see that this A and D not visible. Similarly, you can see that bottom face B1 dash which is visible and C1 dash which is visible, but A1 dash and T1 dash not visible. So similarly you can write so O1 dash and O dash. So that is 1 T. So now we have done with the first position, top and front view. So second position, we know that we have to give the angle of inclination to the right side. Okay, angle of inclination to the right side. So second angle of inclination to the HP, here they have mentioned 45 degree. So what is the procedure here to do it? So first we will be taking this reference point of C1 dash D1 dash reference point. By taking this reference point using the protector, you can keep the protector here exactly and mark for here in the right side from here 10, 20, 30, 40, 45. So mark for 45 degree angle and draw an angle line here. Okay, draw an angle line. So that is for 45 degree. After say first taking the reference point and keeping the protector and marking it for 45 degree and drawing an angle line, what is the thing? Next you have to take the compass and measuring from C1 dash to B1 dash, you need to cut dark. Okay, you have to cut dark. This is B1 dash and A1 dash, and the second arc you have to cut it from C1 dash to O1 dash. This is O1 dash. Okay, so after cutting this arc, so this is the length we require, right? So this is the length. So after this, say we have been drawn the bottom part of it. So these vertical lines we have to draw. You see that these three vertical lines are exactly perpendicular to this base line, right? So you have drawn the base. So what you do, you take the protector, keeping at this reference point, you mark for 90 degree. So here you have to keep it the protector and mark for 90 degree. Similarly, you have to keep the protector and mark for 90 degree. After drawing the 90 degree, this length we know it is 65. Using a straight line scale, you can draw a straight line here. Okay. So draw the straight line and then run it using a scale. So this is B dash, A dash. This is O dash, this is C dash, D dash. Okay. So now, so you can extend this axis because the angle of inclination it is given with the axis. If you extend this axis and measure the angle, you will get exactly 45 degree. Okay. So now we will project it downward to complete the second position, top view. Okay, so for writing the notations, so you have to consider either the first face first or the bottom face. First I am considering bottom face here. You can see that. So here they are merging. This is A1, this is B1, this is C1, this is D1, and this will be O1. Similarly for the top face also, for this one also we can write. So this is A, this is B, this is C, this is D, and this is A. Okay, so you have done the namings. Now you see the concept here. So here it involves 3 steps to construct the second position top view. First thing is you need to draw an outer line. Okay, remember it. So first we have to draw an outer boundary line. You can see that I'm starting from the A1 point. So A1 to B1, so that's an outer boundary line. Then B1 to C, okay, B1 to C. So it is another outer boundary line. Then from C to D, then D to E1. So this forms an outer boundary, that is A1 to B1, B1 to C, C to D, C to A1. So that is the first step, outer boundary line. Now, if the second step in writing the second question is seeing for the visible faces and visible edges. Say we are looking this thing from the top view, right? Looking from the top view. So you can see this in this diagram. We are clearly able to see the top face of this sphere prism, right? That is top face. It is visible like this. It is inclined like this. We are able to see from the top view this face. This face is exactly visible from the top view. So that is. So this pair is visible, so we can join this ABCD. So that is the square we get it. So similarly, you can see that this edge B dash A dash B1 A dash, this is also visible. It is already written with the continuously. Okay, that's what the second step. Second step is writing the visible faces and visible edges. Okay. Now the third step is writing the hidden face and hidden edges. So you can see this bottom face not visible from the top. Okay, bottom face that is not visible. But already we have written a part of it, okay, part of the square. But the remaining part we can show it with the dashed line here, okay. So that's what a dashed line. So in this we cannot able to see this B1 and C1 here, okay. That's what the thing. And then you can see that there is another this face also not visible, that is C1 D1 to D and C1 to C, but already we have written a continuous line. Okay, no need to show. Now you can show the axis line here. Okay, so that's what the axis line. Now in the third position you can see that. So you can see that one of its edges of the base which is inclined to VP at 30 degree. We know that in the normal type of problem, one angle of inclination will be there with the axis. Okay. And then another angle of inclination will be there with the edges of the base. Okay, base edge inclination. So what we do? So we have to draw an angle line here. Okay, angle line here. So what we do initially, we draw a straight line here. Okay, smaller line parallel to the XY. Okay, parallel to the XY. So here I am making the reference point. So you can keep the protector here, and mark for how much angle. So angle here given, that is 30 degree. So mark for 30 degree and draw an angle line. So draw an angle line. So this is 30 degree. So now what we have to do? So if say see that. So this is what the base edge. Okay, this is CD1 D1. You can see in this problem also we are inclining like this, inclining with the C1 D1. That's what the base edge. So we have to take this base edge. You can see in the question also. So one of its edges of the base which is inclined to be at 30 degree. That is taking this D1 C1. So we have to make it resting on this angle line. Okay, how to do that? So I'll be taking first a reference point of D1 here. Okay, then measuring from compass, measure from D1 to C1 and cut the arc. This is the actual line, right? So D1 C1. So we have cut it. Now we can see in this question. So to this line, to this D1 C1 line, these two lines are exactly perpendicular, right? Exactly perpendicular. So what we do here, you take the protractor and mark for 90 degree on both sides, because these lines are exactly perpendicular to this. So taking the protractor, mark for 90 degree on both sides. Okay, you keep the protractor here, mark for 90 degree. Similarly, you keep the protractor here, mark for 90 degree. So after that, what we do, we will be drawing a straight line here. Okay, straight line here. Okay, straight line. So after that, what we do, you take the compass, measure from D1 to A1. You can cut the arc. This is A1. Similarly, C1 to B1, you can cut the arc. So that is B1. Okay. Now similarly, we have D1 to A1 also. You can cut the arc. D1 to A. So D1 to A also you can cut an arc. Okay. Similarly, C1 to B also you can cut the arc. Now from A to D also, by measuring from compass, we can cut the arc A to D. Okay. A to D. Similarly, from B to C also you can cut. Now we left with this O1 and O. You can see that you can cut that from A1 to O1 and B1 to O1 using the compass. Okay. So we are going to cut arc. This is O1. Similarly, we have A to O, the arc, then B to O. Okay. So now after cutting all this arc, so using a scale, you can join all these things. So join all these things using the scale. So this is the second diagram we have copied to the third position. Okay. So now we have to complete the final position here. Okay. So how to do the easiest method here is, easiest method is, first I'll be drawing this, writing the notations of this top face and the top face, and then bottom face and the bottom face. Okay. First I'm finishing with the top face. You can see that. So draw a projection line till here only. So where it is the D dash, here we have this is D dash. Okay. Similarly, we can write for C dash also. C dash also we get it here only, right? So this is C dash. So similarly, we can write project only till where our any point we get it is A dash. This is B dash. So similarly, we have this O point. Okay. This is O dash. Okay. So understood, right? Top face of this and the top face of this are getting here. Similarly, now we see the bottom face. So here the bottom face we have, this is D1. So here we have D1 dash. Similarly, this is C1 dash. Okay. And A1 is here. We are getting this A1 dash here. Similarly, we have this is B1 dash. And here it is exactly here we have O1 dash. Okay. So now we have done with both bottom face notations and top face notations. Okay, this is how we have to do it. Now, for writing the final position, we have here concept that. So we have to see the nearest point to the XY line. So this is our XY line. The nearest point to the XY line, it is D here, correct? So you can see that the D is the nearest point. I will write here. So the D is the nearest point here. Okay. So nearest point is D. You can see that D is connected with which other? D is connected with C and D is connected with A. Okay, and D is connected with D1. It is like this. It is inclined like this. It is inclined like this. So this is what the D point. Okay, D point. So D point, it is connected with C. D is connected with A, and D is connected with D1. Okay, like this. D is connected with C. D is connected with A. D is connected with D1. Okay, these are the near connected points to it. So D is connected with C, and D is connected with A, and D is connected with D1. So these are the dashed lines. Okay, first we will finish with the dashed lines. That's all the concept. Take the nearest point. After taking nearest point, see that which are the adjacent points. D is connected with C, D is connected with A, D is connected with D1. Okay, so those are the dashed lines. So D dash to C dash. So this is a dashed line. So this is a dashed line. Then D dash to A dash. That's also dashed line. Then D dash to D1 dash. You can see that from here to here. Okay. So we have drawn with the dashed line. You can see that D dash to C dash, D dash to A dash, D dash to D1 dash. Then the rest of the thing, it is only with the written with the continuous line. First I am writing with the top face. Okay, the top face it is written. Similarly, the bottom face. So using a scale, you can do it. So you can see that A dash, B dash, C dash connected with the top square, bottom face it is done. Now the vertical edges, say from A dash to A1 dash, B dash to B1 dash, C dash to C1 dash. So straight vertical line using a scale you can do it. Okay, so C dash to C1 dash. Similarly we have B dash to B1 dash. Okay, so this is what we done. Now we have to draw an axis line. Say axis line from O dash to 1 dash. So we are showing with the axis line. So understood, right? So how to write the final position here it is. First take a reference nearest point XY line D. Okay, 1 point. D is connected with C, A and D1. These are the dashed line. First we have done with the dashed line. D dash to C dash, D dash to A dash, D dash to D1 dash. After that what we did? So after that remaining part we have written with the continuous line. Okay, so that's how we complete the first problem in projection of solids.